Okay, it's time for us to level up our division skills, and we could totally do this. When you look at the problem I have here, which is problem 6 on your homework, the thing you'll see that's different is we have a decimal number, but it's the divisor. So we're asking how many groups of 9/10ths can we make out of 63. Now, I'm going to tell you a little secret, and then I'm going to erase it. This would be like saying 63 divided by 9/10ths, right? And we know how to do that. Keep, change, flip, blah, blah, blah. But we got to do it decimal style. Although you could check it if you so wanted to with fractions. Okay, so here's our problem. When we set up a problem like this, we really don't want to have a decimal in the divisor. So we're going to create an equivalent problem, like an equivalent fraction, where we will get the correct quotient even though we've made the numbers larger by some factor of 10. Because we have a tenths place decimal, we can imagine ourselves multiplying that by 10, and 9/10ths times 10, right, equals 9. Here's the trick though. If you do this to the divisor, you then have to do the same to the dividend. That's that equivalent fraction part. Just like if it were a numerator and denominator, both sides have to be multiplied by 10. And 63 times 10, not a problem for any of us. So now we have a problem that looks very much like a 4th grade division problem. How many 9s are there in 630? When we figure out how many 9s are in 630, we'll know how many groups of 9/10 there are in 63. Let's give this a shot. Well, I know that 9 times 6 is 54. 9 times 7 is 63, isn't it now? So 9 times 7, if that's 63, bam. And you might think, ooh, I'm done. Except for remember, you don't have anything in the ones place right now. Well, how many 9s are there in nothing? Well, there are 0 9s in nothing. There you go. So guess what? Same over here. Same over here. How many groups of 9 are in 630? 70. How many groups of 9/10ths are in 63? 70. So that is the quotient. So the idea behind this is creating this equivalent. If that sounds a little confusing to you, in my next problem, I'll talk about it in shortcut terms that might work better for you. But this is the bigger math idea underneath for folks who are ready. Okay, so here again we've got a problem where we're being asked to make groups that are very small. That is a decimal number under 1. How many 800ths are in 72? Well, that's just crazy. So here's the shortcut thinking. It's not my favorite, but we can imagine it. If I've got a decimal in the divisor, I'm just going to quickly turn my whole number into its decimal equivalent, which is just a decimal and a 0. From here, here's what I want to be able to imagine happening. And again, this is like crazy shortcut math. To quote unquote get rid of the decimal in the divisor, I have to move it 2 places to the right to turn that into an 8. If I move it 2 places to the right in the divisor, I'd have to move it 2 places to the right in the dividend. And you might be thinking, but that leaves a weird hole. We all know what goes in the weird hole. We all know what we use is a placeholder. Now, really what we just did is we multiplied 800ths times 100, which is 8, and then we took 72 times 100, 7200. We did the same thing we did before. It's just that in the first example problem, I explained it correctly in this way. I'm just showing you this as a shortcut. If we move 2 over in the divisor, we move 2 over in the dividend. Not a great way to understand it, but it might be the best way for some of us. All right, from here, again, this is now a 4th grade level problem. How many 8s in 7? Well, none. How many 8s in 72? Well, last time I checked, 8 times 9 was 72. Haha. And that means, what do I put in the 10s and the 1s if I just have zeros left? Well, I put zeros there because there are no more groups of 8 here. Now, it turns out that 8 times 900 is 7,200. And it also turns out that 800ths times 900 is 72. This is an equivalency situation, right? Our original problem is equivalent in terms of the quotient we end up with, the relationship of the numbers, to the problem we actually use to solve. All right. One more example. So here we have this problem. A cookie cutter shark is 4/10 of a meter long. Oh, adorable. And a thresher shark is 6 meters long. Oh, deadly. How many times as long as the cookie cutter shark is the thresher shark? Well, to figure this out, I have to figure out how many groups of 4/10 I can get out of 6. So again, I'm going to need to create an equivalent problem because I have a divisor with a decimal in it. I can imagine how we get the decimal out. Well, to turn this 4/10 into 4, I'd have to multiply it by 10. Or I can think of it as moving the decimal over 1 to the right. I kind of hate that, but it can be done. Either way I think about it, it's 4. And I have to do the same thing, my friends, over here to the 6. So I'm going to turn it into a decimal, and I can think of it as times 10 and times 10 again, or I can just imagine that decimal moving over one place to the right as I did with the dividend. And it turns out that the relationship between 4/10 and 6 is the same kind of relationship as 4 and 60. So now I have a problem that, hey, some of our 3rd graders might be able to rock this, so let's see if you can rock it. If you haven't yet, this is a great place to pause and do the work yourself and then check by watching the rest of the video. Because again, whoever does the work gets the benefit. So if you're not pausing to try problems, you're probably not going to remember any of this and you're going to feel helpless. Well, then watch it again, pause, and try to do the work yourself before you watch me do it. How many 4s are in 6? 1 group of 4, and that leaves me with 2. I bring down the next digit. How many 4s are in 20? Well, 5 groups of 4. Happens to be 20. No remainder. So how many times as long as the cookie cutter shark is the thresher shark? It's 15 times as long, to use the language from the question in the answer. So here are 3 examples. Again, go back and watch them. When you are working on the problems, these 3 examples are 3 common examples that you could use to help you work through any problem in the homework to develop some skill with what we do when there is a divisor that is also a decimal. Alrighty, that's it for now.